Good afternoon, everyone. Welcome back to my YouTube channel. Today, I'm going to be taking you guys on Cal 1, that's Calculus 1. That's the basic calculus any engineering or math student need to know, specifically differentiation of inverse trig functions. So, I'll begin with this. First of all, you need to know this. This is one of the trig identities you need to know. Plus 1 plus sine squared x equals to 1. This is very important. Put this down. This is very important. So let's begin. So question 1. Y equals to sine inverse of 2x plus 3. Okay. First of all, the first step for solving this question, you get rid of this sine inverse. How do you get rid of this sine inverse? By multiplying both sides by sine. Look at this. Sine y equals to sine inverse of 2x plus 3. That's the next step. So this sine will cancel this sine inverse. So you are going to get sine y equals to 2x plus 3. What's the next step? The next step, you differentiate both sides. Differentiating both sides. That's if you differentiate sine y, what would you get? You get cos y. With respect to what? Y. That's you add the y. That means you were differentiating sine with respect to y. So the y must come in. Then in your right hand side, you have 2x plus 3, right? You have 2x plus 3. If you differentiate 2x plus 3, what will you get? You will get 2 dx alone. Understood? So now, what's dy over dx? Now, finding dy over dx, you divide both sides by dx. So this should be gone. So you are going to get cos y dy over dx equals to 2. Now let's take this to this other side. That's the next step, making dy over dx stand alone. Let's take this to this other side. That means divide both sides by cos y. Divide both sides by cos y. This will cancel off. So your dy over dx equals to 2 over cos y. This is not your final answer. You need to express your final answer in terms of x. Now, this y here, you are expressing your final answer in terms of y. Except you are asked to do so, you can keep it like this. But if you are not asked to do so, know that you are needed to express your answer in form of x. So now, so from here, we have sine y equals to 2x plus 3. First of all, let's get here. This is cos squared x plus sine squared x. So you already said that your sine y here equals to 2x plus 3, right? So now we are going to have sine squared x plus cos squared x equals to 1. So now, since we have y here, we are going to express it in terms of y. That's sine squared y plus cos squared y equals to what? 1. What's the next step? You endeavor to find this cos y. Make from here, you can make cos y subject of the formula. Making cos y subject of the formula, that means cos squared y equals to, carry this here, 1 minus sine squared y. So from here, how do you get rid of the square in the cos y? Taking square root of both sides. So when you take square root of both sides, that's square root of cos squared y. You also know that cos squared y can be expressed like this, cos y squared. Hope you know this. So equals to the square root of 1 minus sine squared y, right? So that your cos y will be equals to the square root of sine, square root of 1 minus sine squared y. So now this is your cos y, right? Now come back to this equation here. The y over the x equals to 2 divided by what? Cos y. Now, what's your cos y? Your cos y equals to the square root of 1 minus sine squared y. So the y over the x equals to 2 divided by square root of 1 minus sine squared y, right? So that your dy over dx will be equals to 2 over square root of 1 minus. Now, what's going to be your sine y? Your sine y is 2x plus 3. Now, first of all, let's expand this. Sine y squared, right? Now you just need to carry in your sine y, plug it in here. What's your sine y? Your sine y equals to 2x plus 3. That's dy over dx equals to 2 divided by square root of 1 minus 2x plus 3. That's the sine y. Then don't forget the square. You are done. That's your answer. So we are going to go ahead and solve the next question. So what's the next question? The next question is y equals to cos inverse of sine 5x. Cos inverse of sine 5x. Alright? Cos inverse of sine 5x. Now, cos inverse of sine 5x. Now, first of all, you get rid of the inverse trig here. That means multiplying both sides by cos. So that's going to give you cos y equals to cos inverse of sine 5x. So that's going to get rid of the cosine, cos and the cos inverse. So your cos y equals to what? Sine 5x. Now you differentiate both sides. That's the next step. Don't forget to differentiate both sides. Now let's take the derivative of this left hand side. If you differentiate cos, you are going to get minus sine, right? So that's minus sine y. Then if you differentiate sine, you are going to get cos, right? So sine 5x. If you differentiate sine 5x, you are going to get 5 cos 5x. Please note that using chain rule, let me highlight it somewhere here. Sine, for example, u equals to sine 5x, right? So you can call your q 5x so that your u will be equals to sine q. Now let's find the u over sine. Let's find the u over the q. The u over the q equals to cos q. Alright? Let's find the q over the x. The q over the x equals to just 5. Right? So using chain rule, your du over the x is going to be equals to du over the q times the q over the x. So that your du over the x will be equals to what? Now du over the q is what? Cos q, right? Cos q times the q over the x is what? 5 times 5. So now you get your du over the x equals to, what's your cos q? Your cos q, now your q is just 5x. So impute it cos, okay, this will be 5 cos 5x. So this is it. Just highlight it somewhere. So that's why if we differentiate sine 5x, we are going to get 5 cos 5x, right? We are not done. So please don't forget this. You are differentiating with respect to y, put your dy. You are differentiating with respect to x, put your dx. Now next step, find dy over dx. Divide both sides by dx. So minus sine y equals to minus sine y dy over dx equals to 5 cos 5x. This is gone. Okay? So making dy over dx subject the formula. So dy over dx will be equals to 5 cos 5x divided by minus sine y. But we are expressing an answer in form of what? X. Now this is y here. We need to get rid of the y. So remember, cos squared y plus sine squared y equals to what? 1. So how do we get sine y? So bring this over here. So sine squared y equals to 1 minus cos squared y. So your sine y equals to what? Square root of 1 minus cos squared y. Now your sine y will be equal to square root of what? Now 1 minus cos squared y. So that's cos y then squared. So your sine y will be equals to square root of 1 minus. Now what's your cos y? Come back here. Your cos y is just sine 5x. Your cos y is just what? Sine 5x. Impute it here. So that's going to be sine 5x what? Squared. We are not done. So this is the main equation here now. So dy over dx equals to 5 cos 5x divided by minus sine y. But here, we can express this sine y to make it more less. Now look at this. Sine y equals to square root of 1 minus sine squared 5x. Now recall that your sine squared x plus cos squared x equals to what? 1. Note this. Then 1 minus sine squared x equals to what? Cos squared x, right? So same thing applied here, sine 1 minus sine squared 5x. That means that sine squared 5x equals sine squared 5x plus cos squared 5x equals to 1. So your cos squared 5x equals to what? 1 minus sine squared 5x, right? So just bring it here. That means you get here, the whole of this will be replaced with cos squared 5x, so that your sine y equals to square root of cos squared 5x. So that sine y equals to just cos 5x. So now you can carry that and plug in here. That's dy over dx equals to 5 cos 5x divided by minus, what's your sine y? Just cos 5x. So cos 5x. So it will cancel off. Cos 5x will cancel cos 5x. You will be left with dy over dx equals to minus 5. This is your final solution. Very, very easy. This is your final solution. Cos 5x has cancelled cos 5x. This is cos 5x. So cos 5x has cancelled cos 5x. So your answer is minus 5. Before you question why is there minus sign here, referring back to the main start where we solved on the first board. Now look at this, cos y equals to sine 5x. Now when you differentiate cos y, what do you get? Minus sine y. You understand my point? So that's why we add that minus here till the very end. That's the minus sine y. So when we solve, there was nothing to get rid of the minus was still there. So the answer is minus 5. So let's solve the next question. So solving the next question, that's question 3. Your y equals to sec inverse of ln 2x. That's ln 2x. What's ln? Ln is a natural log function, okay? So some people might see this, they'll feel scared, it's too hard, but it's not hard. Okay, this is what we'll do. So first of all, get rid of the trig inverse. So multiplying both sides by sec. So you get sec y equals to sec, bracket open, sec inverse of ln 2x or ln 2x. I don't know how you guys call it, but I call it ln 2x. So sec y will be equals to what? Ln 2x. That's ln 2x, because this sec has cancelled off this sec inverse here. Now you differentiate both sides. That's the next step. Okay, for differentiating ln function, if you want to differentiate ln function, that's For example, you have y equals to ln x. Now, finding the y over the x. The y over the x will be equals to 1 over the function. That's 1 over this function. This is f of x. That's 1 over f of x times the derivative of the function. That's times the derivative of this function here. That's f prime of x. Understand my point? That's, for example, if it was, okay, this is x here. Now it will be 1 over what? X times derivative of what? Derivative of x is what? Just 1. If we add ln x squared, that means that this, if you differentiate, it will be 1 over x squared times the derivative of x squared is what? 2x. So put it here. Very simple. That's how to differentiate natural log functions. So the next step, differentiating both sides. So if you differentiate sec y is constant. We all know that differentiating sec y will give us sec y tan y. It will give us sec y tan y. Please, you should know some of these constants. Without, you can learn to memorize them and somehow cram them. So, but I don't advise my students to cram. They should know how to derive the answers. So sec y, how will be sec y tan y dy. Remember, you are differentiating with respect to x. So now differentiating ln 2x, that will be 1 over the function, that's 2x, times the derivative of the function. What's the derivative of 2x? It's just 2, right? Times 2. Now, don't forget, you are differentiating with respect to what? X in the right hand side. That's going to give you the x here. Now, 2 will cancel 2 here. Right? So, sec y tan y dy equals to what? Dx over what? X. We are not done. So, dy, getting rid of this dx here, that's times 1 over dx. So, that will give us sec y tan y equals to what? Sorry, dy over dx equals to 1 over what? X. So, now, getting rid of sec y tan y to this other side. So, we are going to get dy over dx equals to 1 divided by sec y tan y times x. Okay, look at this in case you are confused. Now, dy over dx times sec y tan y. Now, if you want to eliminate this sec y tan y, you are going to multiply it with 1 all over sec y tan y, right? That will be sec y tan y equals to 1 over x. Then that's the same thing applied here. That's going to be divided by sec y tan y. So that this one will get rid away, and dy over dx equals to 1 divided by x. Then divided by sec y tan y divided by 1. So that your dy over dx will be equals to 1 over x. Then this sign will change to multiplication sign. Then the function we have in the right hand side will interchange. So that will give us sec y tan y. That's how I got here. So from here, we will find a way and eliminate sec y and tan y, making it in form of, making this function in form of what? X, in term of x. Let us not keep it in term of y. So what next? Now we have here tan sec y tan y, right? Now let's expand this. Sec y is just 1 over cos what? Cos y. Then times tan y is just sine y over cos y. So that's sine y over what? Cos y. So this will be sine y divided by cos squared y, right? Now don't forget that sine squared y plus cos squared y equals to 1. Right? So this is just equals to 1. This here is just equals to 1. But from here already, okay, not punishing ourselves. Let's get back to here. Sec y is just equals to ln 2x. Sec y will come back to here. Please note this below. We'll come back to here. Note below that your sec y is already, your sec y is what? Your sec y is already ln 2x, right? So that your dy over dx equals to what? Your dy over dx equals to 1 over sec y. Sec y is ln 2x. So that's x, this x here times ln 2x times tan y. Alright. So now it's just left for us to eliminate this tan, change this tan y into form of x. So how do we do that? So this here, okay, this one was sec y. So let's just work with tan y. Let's work with tan y alone. So tan y equals to sin y over cos y, right? So that your this 1 over cos y times sin y. So this will give you what? Sec y sin y. This is another correct expression for this. Sin y sec y. So we also have another expression. Sec y sin y. Sec y is what? ln 2x. So let's come back to here. dy over dx equals to 1 over x ln 2x. That will be sec y sin y. So dy over dx will be equals to 1 divided by x ln 2x. Sec y is still times ln 2x, then sin y. Sin y. So now your dy over dx will be equals to 1 divided by x. Now ln 2x is what? ln 2x times ln 2x will give us ln squared 2x, then times sin y. How do we get rid of sin y? Now this will be a little trickish, but follow up with me. We can eliminate this sin y, changing it into form of x. Now from the beginning here, we add sec y equals to ln 2x, right? So that 1 over cos y equals to ln 2x. Now make cos y subject of the formula. Let's make cos y subject of the formula. Cos y, if you want to make cos y subject of the formula, 1 over cos y equals to ln 2x, cross multiply, so that cos y ln 2x equals to 1, so that cos y equals to 1 over ln 2x, right? So what will be your sin y from here? So recall sin squared y plus cos squared y equals to 1. So now, what do we have here? We have sin y. So let's make sin y subject of the formula. Your sin y will be equals to square root of 1 minus cos squared y, so that sin y is already equals to square root of 1 minus cos squared y. Then coming back to your dy over dx, your dy over dx equals to what? Okay, your dy over dx equals to 1 divided by x ln squared 2x, then times sin y, right? Now we have an expression for sin y, so let's replace it. Dy over dx equals to 1 divided by x ln squared 2x. Sin y is square root of 1 minus cos squared y. So dy over dx will be equals to 1 divided by x ln squared 2x, Now square root of 1 minus, now what's your cos y? Cos y is just 1 over ln 2x. So impute it here, 1 over ln 2x. Then don't forget your squared. Then your squared. So your dy over dx equal to 1 divided by x ln squared 2x times the square root of 1 minus 1 squared is 1. Then 1 ln 2x power 2 is just ln squared x. So that's 1 divided by ln squared 2x. So this is your final solution to the question. Let's get to question. So let's solve the fourth question. Question 4. Y equals to tan inverse of exponential 5x. But first, let's get somewhere. Let's derive something. Sec squared y plus tan squared y equals what? We don't know. Let's find out. Sec squared y is just 1 over cos squared y, right? Plus tan squared y is sine squared y divided by cos squared y, right? So LCM is just cos squared y, then cos squared y divided by cos squared y is what? 1 plus cos squared y divided by cos squared y is just 1 times this sine squared y. So this will not work. This won't work for us. We'll change the sign. Let's change the sign. Let's change the sign here. Minus. Let's change the sign here. That's sec squared y minus tan squared y. So let's also change the sign here. Then change the sign here. So now 1 minus sine squared y is what? Cos squared y. So you are going to get cos squared y divided by cos squared y, which equals to 1. So that means sec squared y minus tan squared y equals to what? Just 1. This is another thing to note, please. Very important. Another thing to note, that sec squared y minus tan squared y equals to just 1. So now, solving this question, taking tan on both sides. So that's tan y equals to tan inverse of exponential 5x. So this should be gone, but tan y will be equals to exponential 5x alone. Differentiate both sides. That's the next step. Differentiating tan y, you get sec squared y. Note that. So this will be sec squared y. You are differentiating with respect to y on the left hand side. So don't forget your dy. Equals to, now, it's a differentiating exponential function. Differentiating exponential function, it will be derivative of the function on top times the repeated function, like this. This is exponential 5x. Now, differentiate this. If you differentiate 5x, it will give you what? 5. So bring the 5 down. Times, repeat the whole function itself. Exponential what? 5x. So this will give you 5 exponential what? 5x. Please note that. That's how to differentiate exponential functions. So this will be 5 exponential 5x dx. We are not done. Let's make dy over dx subject of the formula. So dy over dx will just be equals to 5 exponential 5x divided by sec squared y. Now let's refer back to this. Sec squared y minus tan squared y equals to what? 1. So sec squared y minus tan squared y equals to 1. So that your sec squared y equals to 1 plus tan squared y. Now this is sec squared y, this is sec squared y. We can replace our sec squared y as this. So dy over dx equals to 5 exponential 5x divided by 1 plus tan squared y, right? So now, coming back here, what's your tan y? Your tan y is what? Exponential 5x. So dy over dx equals to 5 exponential 5x, then 1 plus. Now tan y is what? Exponential 5x. So if you square it, you will get exponential what? 10x. So this is your final solution. Please, thank you. If you have any question, drop it on the comment section. I'll be there to reply. See you in the next class. Thank you.